Is helium-3 the real reason for the modern day space race? Could there be an undetectable death ray coming towards us? Where's the best place to stargaze? And in Q&A Plus, where will the Artemis missions land? All this and more in this week's Question Show. It's time for the Question Show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, I'll gather them up, and I will answer them here. All right, let's get into the questions. Ravi, good, better, best. Do you think mining helium-3 is the real reason for this new moon base race? No, absolutely not. Helium-3 is this sort of isotope of helium. And one of the, it's thought that the advantage of using helium-3 in your fusion reactors is that you get less dangerous radiation coming out of the reactor. And I forget the exact atomic explanation for this, but with normal hydrogen fusion or with normal helium fusion, you're going to get an excess of gamma radiation coming out of your reactor. But if you do this helium-3, then you get less of that gamma radiation. And so that would allow you to have a fusion reactor that is in a tighter space, closer to people, and you can worry about it less as causing radiation damage. And helium-3 is located here on Earth. I mean, it's in deposits of helium, which are part of, say, oil and gas reserves and things like that. But because helium-3 is being generated by the sun, this stuff is implanting on the surface of the moon, and then it has a much higher ratio of helium-3 in the regolith than what you might find down on Earth. And it's not nothing. It is definitely something, but the first step for where you would want to actually have your helium-3 is that you would want to be able to have a fusion power. And at this point in the technology curve of humanity, we do not have controllable fusion power. We have uncontrollable fusion power. We have thermonuclear weapons. We know how to harness the power of the sun to release megaton weapons, but we don't know how to do this in a controlled manner. The classic joke is that fusion power is always 30 years away. And we're at a point now where there is a huge facility that's being built in Europe called ITER. The Germans are working on their version of a fusion reactor. The Chinese are working on a bunch of fusion reactors. There's a bunch of startups in the United States that are working on fusion reactors. And I'm guessing that we're about 30 years away from fusion power, which, what do you know? We're always still. And so think about it. And that's not just even hydrogen fusion. We'll probably start in deuterium fusion, which is going to be an easier form of fusion, then probably move to tritium fusion, and then move to proper hydrogen fusion, and then maybe move to helium-3 fusion, and then work out miniaturization. We are 50. Well, no, I mean, come on, honestly, fusion's 30 years out. Then helium fusion, like maybe 100 years out. So although when we get to a place where we do want to have helium fusion, we will be able to, then we'll be able to go to the moon and pick up some of this stuff. But that feels like a real long shot. So no, the race for the moon base is to put a base on the moon. That there is, real, genuine scientific inquiry that can be done on the moon. It is a valuable place to go for science. You have just the geologic questions you have about the moon itself. You have the regolith and how the regolith serves as a time capsule for all of the events that have happened in our vicinity astronomically. And then you have the observations that you can make from the far side of the moon using radio telescopes. And both the Americans and the Chinese are trying to set up a base on the moon. And, part of it, of course, is to demonstrate your technological superiority. Like we can put a base on the moon. We are really good at what we do. But it's also just important to just say that all nations invest a certain amount of their production into scientific inquiry, and that there are scientific questions that can be answered by the moon. And so both the United States and Europe and Canada and Japan and the Chinese are doing science, and the moon is a platform to do that science. It's crazy to me that we cannot plan very far into the future. We're just not that organized about that kind of stuff. And so I always say, don't worry about people stealing your ideas. If your ideas are any good, you'll have to jam them down people's throats. If we get to a place where helium-3 is finally viable, then maybe people are going to consider, should we harvest this from the moon? But even then, probably not. Slow boy fuel pump. What is the best place in the United States for stargazing? I mean, in general, I mean, this is the general advice for what are the best places to go stargazing, is that you want a place that has very dry air, a place that does not have a lot of moisture in the atmosphere. And so in the United States, the best places are in the Southwest. So think like Arizona, New Mexico, Utah, Nevada, that kind of thing. And you also want a place that is very far away from light pollution. So once you get, I don't know, like to the Mississippi and then to the east, all of the, light pollution is impossible to escape from. But once you go out into the west, then you can be really far away from various city centers and get truly dark skies. There's this scale called the Bortle scale, and you can sort of seek the darkest skies using this Bortle scale. And then the last thing that you want is some kind of altitude. The higher up you can get, the less of the atmosphere is above you and the more of it that is below you. And so if you can go up a mountain in the southwest of the United States, in a place that is very far away from the city, you will have the most pristine skies possible. And in fact, there are a lot of observatories in the Southwest. There's a lot of them around, the Tucson area, and you can often go up to those observatories in the summertime, and you can set up your own telescope and you can take advantage of the really dark skies that they have up there as well. And of course, the other place that is incredible is Hawaii. Not so much when you are close to the water, but you've got these giant mountains on the big island of Hawaii and on Maui that you can go up to the top of these mountains or get pretty high up and then set up your telescope, and the seeing is the best in the world. The largest observatories in the world are set up on the big island of Hawaii for a good reason, because it is a great place to go. So the Southwest in the United States or Hawaii. It's time to shout out our new patrons at the $5 level and above: Norbert, Paul Scott, Mark Kruger, Matthew Holmes, Brian Hager, John, Olivia Jimenez, David, John Fellows, and Tom Tyndall. Join the community at patreon.com/universetoday. D.O. What's your favorite naked eye or low magnitude observation? Man, doing astronomy with the unaided eye, with the naked eye, is tricky because there's not a lot that you can see compared to what you can see with a telescope. But what your eyes can see is a very wide field of view, which is a thing that your telescope can't see. And so I think the things that I like the best are when you have interesting conjunctions. So you've got like a crescent moon, and it's very close to Jupiter, and maybe Jupiter and Venus. And so you've got this almost smiley face up there in the sky. And that just looks great. And you can see that with the eyes, right? The other thing I really like is to be able to just see the Milky Way, where you've got this big wide view of the Milky Way from horizon to horizon. And you've got to be in like really dark skies to be able to see the Milky Way. But if the skies get dark enough, the Milky Way is just incredible. The other thing that I've seen once in my life is the Large and Small Magellanic Cloud. You can only see those from the Southern Hemisphere. So I was traveling in Australia, and I was able to see the Large and Small Magellanic Cloud. That was very cool. And then the one that is like dramatically better, that no camera or telescope can really capture, is the Northern Lights, the Aurora Borealis, the Southern Lights. That when you see pictures of the Northern Lights, you see these kind of really cool streaks in the sky. I think your thought is that this is something that is kind of very slow moving, that it's just this thing and you're taking this long exposure and you're getting these weird ripples in the sky. But it's nothing like that. It is alive. It is moving. You can see this sort of shimmer that goes across the sky and it goes the other way. And you can see it, and especially if it's happening like right above you, then you get these almost like snakes in the sky, and they're twisting and turning. And it just, watching video, seeing pictures of it, it just doesn't capture what it's like to watch this with your own eyes. And so that's the kind of stuff that I really like. I would say the other thing is meteor showers, that when you're outside and you're watching meteors go by, hopefully you've all seen a meteor in your life, but you see this point of light go across the sky, and you can see the trail of the meteor in the sky, and then you can watch it as it's like fades away, and the ones that are much brighter, they look better than the ones that are a lot fainter. And again, you just you can't capture that as a video. And so, yeah, I'd say that's kind of stuff that I enjoy doing just naked eye astronomy with. Kevin Jelezniatsky. Is it possible that radiation from a supernova or a burst of energy somewhere is traveling towards us right now and can destroy the Earth, or at least all life, or are we just too far away? Yes, it is possible that there is a burst of energy that is heading towards the Earth right now that could cause a mass extinction on planet Earth. So we've got to sort of think about the kinds of sources that could cause that kind of destruction. And the one that people think about is, say, a supernova, right? That if a star goes supernova and it is relatively close to us, then we will be doomed. But a supernova has to be really, really close. It has to be like 25 light years away from us. And there are no stars capable of going supernova within 25 light years of us. There are stars that are in the few hundred light years away from us that are capable of going supernova, but if they do, then the damage they would do is not meaningful, and so we don't have to worry about this. And the kind of damage that you're looking at is mainly that when the radiation arrives at Earth, it destroys the ozone layer and allows more radiation to get into the planet than it normally would, and then life on Earth dies because of increased amounts of radiation. That's the big risk that we face. So then there is another kind of explosion that is more dangerous than a supernova, and it's called a gamma ray burst. We're not still entirely sure what causes a gamma ray burst, but it seems to be a bigger version of a supernova, that you get a star that implodes and it creates these collimated bursts of energy that come out the poles of the star. And if you happen to be staring right down the barrel of one of these beams, then it can cause that same kind of damage. And the good news is that there don't seem to be any of these stars that are relatively close to us, within, and this is the scary part, actually, it gets scarier, but, you could be within the galaxy, that, something could be 25,000 light years away from us. It could fire one of these beams at us, and it could cause that mass extinction on Earth. But astronomers have looked out there for all the kinds of potential gamma ray bursts, and we don't, they don't see any stars that have the potential of blasting us with a gamma ray burst. There was a gamma ray burst that went off in a relatively nearby galaxy. It was more than 10 million light years away from us. It's like not just in the Milky Way, but in an entirely different galaxy. And we happened to be hit by the beam, and the entire Earth's atmosphere wobbled after this beam hit us from several million light years away. So it's certainly believed that mass extinctions in the past on Earth have been the result of this gamma ray burst striking the planet, but they are incredibly rare. We don't know of any stars that have the potential to do this that are close enough to cause damage to the planet. But, could there be one out there? Yeah. So there could be a star that exploded 10,000 light years away from us, and it looks like a star to us today, but in fact it is a gamma ray burst, and the beam of energy is traveling towards us, and at some point that beam is going to wash past the Earth, and we would have a bad day. But astronomers haven't identified any stars that are potential for doing that. So I would, when I think about the kinds of risks that we face from space, we have to be more concerned about the star that is right there inside the solar system, right, with its potential for unleashing very powerful flares that will cause us a very bad day, compared to a gamma ray burst. I really wouldn't worry about gamma ray bursts. And like the scariest possible things are fascinating, but they're very unlikely. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. This week's bonus question: where will the Artemis missions land? I'm going to put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. I'm going to talk about the new media that I am watching, reading, playing. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finga, David Gilton, David Matz, Enthrallo Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smith, Micah Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Feathermoney, Team 49, Telescopes Canada, Vlad Shepelin, Wolfgang Klotz, and Zelda. Sorry, I really wanted to hear you say it. Who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So every couple of weeks, I give you an update on all the media that I am watching, mostly with my wife. So a lot of sci-fi stuff has dropped so far, and we've been catching up. So first, Avatar, The Last Airbender, and this is the second season on Netflix. We watched it. The first season was pretty good. This season didn't feel as strong. On the one hand, a lot of the actors and the sets and the characters are doing an incredible job. I mean, if you watched Avatar: The Last Airbender, which you should, the cartoon, one of the best cartoons ever made, one of the best pieces of fantasy media ever made, the characters are great. And one character is Toph, and Toph arrives in season 2, and the actress that plays her is perfect. It is just dead on. And so a lot of the characters in it they're working really hard. But I find a lot of the script is a little cringy, and I'm not as deeply enjoying it as I really feel like I should be. And like, how could you? Like, you take one of your favorite pieces of media, and then someone makes a live action remake of it. You know, we saw the first time that happened with M. Night Shyamalan's version. This is way better than that, but still, it just like can't capture the magic of the original cartoon. And maybe it shouldn't. Like, maybe it can't. Like, what do I want here? The next show that we're watching is Silo, and we're only one episode into it in season 3. This is on Apple TV, and Silo is terrific. The first 2 seasons were wonderful. So far, you know, we got a new mystery. Things are weird. I don't want to give away anything, but I'm already can't wait for the next episode. And then the last big show that we're watching is The House of the Dragon, and this is season 3 of that. Man, has HBO got money to burn, because the first episode of season 3 is extra long, and just the dragon on dragon combat, the special effects are movie level. It is unbelievable how much money is being spent on this show. And so far, it's great. I'm really enjoying this season of the show. Like, if you watched Game of Thrones, it started off amazing and then kind of went downhill. And when you got into the final seasons where they're really shortening things up, it was very frustrating. But so far, House of the Dragon is kind of moving in the opposite direction, kind of getting bigger and better and tighter. And I'm really enjoying it so far. And we've got 3 episodes in so far. Highly recommended. And then for reading, I'm reading the First Law series, which is by Joe Abercrombie. And this is a fairly like low fantasy series. It's 6 books in the series, and there's like another trilogy of 3. I'm only 2 books in. My son has read all of them, and they're his favorite, you know, this is his favorite book series, except for maybe Dungeon Crawler Carl. But he loves them, and his recommendations are solid, and I've really been enjoying it. And so if you're looking for a fantasy series, but really good characters, excellent writing, highly recommend the First Law series by Joe Abercrombie. The first one's called The Blade Itself. All right, that's all the media. Catch you up on. We'll see you next time.